Solid-state batteries have been promised for decades, but have never reached mass production. Donut Lab argues that the technology is already mature. The company states that its battery is ready to be integrated into vehicles without further development. If this is true, it would represent a major shift in battery technology. The industry response has been both intense and divided. Solid-state batteries differ fundamentally from traditional lithium-ion batteries. Conventional batteries rely on liquid electrolytes to move ions between electrodes. Solid-state batteries replace the liquid with a solid material. This change is believed to improve safety and efficiency. In theory, solid electrolytes allow higher energy density and faster charging. They also reduce the risk of fires and thermal runaway. Despite these advantages, solid-state batteries have been extremely difficult to manufacture at scale. Issues include material fragility, interface resistance, and cost. No major manufacturer has yet delivered a mass-market version. This is why Donut Lab's claim has attracted scrutiny. Donut Lab states that its battery achieves an energy density of around 400 watt-hours per kilogram. This would exceed most current lithium-ion batteries by a significant margin. The company also claims that the battery can be charged fully in approximately 5 minutes. Unlike most fast-charging systems, this claim refers to a full charge rather than a partial one. Another major claim is an exceptionally long lifespan. Donut Lab suggests the battery could survive tens of thousands of charge cycles. This would allow decades of use without major degradation. The company also claims strong performance across extreme temperatures. According to its statements, capacity loss remains minimal in both cold and heat. These specifications together would surpass current industry limits. Independent verification has not yet been published. One of the most controversial aspects of Donut Lab's announcement is the lack of publicly available technical documentation. The company has not released peer-reviewed studies or detailed chemical explanations. Most established breakthroughs in battery science are accompanied by published research. Patents and third-party testing are also usually involved. In this case, much of the information comes directly from the company itself. This has raised concerns among battery experts. Some industry figures have openly questioned whether such performance is physically achievable. The company is working with Verge motorcycles to deploy the battery in upcoming models. These motorcycles are expected to enter production soon. If delivered as promised, they would become the first vehicles powered by a fully solid-state battery. This makes the project especially important. Real vehicles allow direct testing by independent parties. Performance, safety, and durability can be measured outside controlled environments. The motorcycles will provide real-world data rather than simulations. This is the moment when claims will either be validated or disproven. Engineers and analysts are closely watching the rollout. The results will likely determine Donut Lab's credibility. Until then, uncertainty remains. The potential impact of a successful solid-state battery cannot be overstated. Faster charging could eliminate one of the biggest barriers to electric vehicle adoption. Higher energy density would allow lighter vehicles with longer range. Improved safety could significantly reduce fire risks associated with current batteries. Longer lifespan would lower total ownership costs over time. Beyond vehicles, the technology could transform grid storage. Renewable energy systems rely heavily on efficient batteries. Aerospace, robotics, and defense applications could also benefit. However, exaggerated claims could damage trust in emerging technologies. Investors and consumers have seen similar promises fail before. This history fuels skepticism, even in the face of optimism. The stakes are extremely high. At this moment, Donut Lab's solid-state battery sits at the center of a major technological controversy. The company claims it has solved problems that have challenged scientists for decades. Critics argue that the data does not yet support those claims. The truth will emerge once independent testing becomes possible. Production vehicles will provide evidence that cannot be ignored. Until then, the story remains open. This is either the beginning of a new battery era or a cautionary tale about unchecked hype. What happens next will influence the future of electric mobility. The industry is watching closely. The outcome will shape investment and research priorities. Few announcements have carried this level of consequence. Donut Lab frames its solid-state battery as a platform rather than a single fixed product. This means the design is intended to evolve alongside different applications. Instead of locking into one voltage or capacity format, the system is meant to scale up or down. That flexibility is especially important for emerging electric platforms. Smaller manufacturers often struggle to access custom battery solutions. A platform approach allows faster adaptation without redesigning everything. This could benefit startups entering electric mobility. It also appeals to the defense, aerospace, and robotics sectors. These industries require specialized power profiles. A modular battery backbone supports that diversity. Few battery companies emphasize adaptability this early. The company also highlights improvements in internal energy flow efficiency. Traditional batteries lose energy as heat during rapid discharge. Donut Lab claims its internal architecture reduces that loss. More efficient energy transfer means more usable power from the same stored charge. This is critical for performance-driven electric systems. Accelerated heavy applications stress batteries intensely. Reduced energy loss improves consistency over time. It also supports longer component lifespan. Efficiency gains compound across thousands of charge cycles. This directly impacts the total cost of ownership. Fleet operators care deeply about this metric. Small efficiency gains can mean millions in savings. Another important angle is charging behavior under variable grid conditions. Not all charging environments are stable or predictable. Power fluctuations can degrade conventional batteries. Donut Lab suggests its chemistry tolerates inconsistent input better. This is especially relevant for developing markets. It also matters for mobile charging solutions and temporary infrastructure. Construction sites, military deployments, and disaster zones rely on unstable grids. Batteries that accept imperfect power safely are valuable. This reduces dependency on expensive conditioning equipment. It also lowers failure risk during emergency use. Reliability in imperfect conditions is rarely discussed publicly, yet it often determines real-world adoption. Donut Lab also speaks about internal resistance behavior over time. Many batteries perform well initially, then degrade sharply. Rising resistance reduces power output and efficiency. The company claims resistance growth is significantly slower in its design. Slower resistance increase supports predictable long-term performance. This is critical for mission-critical systems. Vehicles that rely on peak power cannot afford sudden drop-offs. Predictability matters more than peak numbers. Engineers design around known behavior. Unstable degradation complicates warranties and safety margins. A stable resistance curve simplifies system engineering. This could be one of the most important long-term advantages. From a systems integration standpoint, the battery is designed to communicate deeply with vehicle software. Modern electric platforms rely on constant data feedback. Donut Lab emphasizes real-time diagnostics at the cell level. This allows early detection of irregular behavior. Software-driven monitoring reduces catastrophic failures. It also enables predictive maintenance strategies. Fleet managers can schedule service before problems escalate. This aligns with trends in smart mobility. Data-rich batteries become part of the vehicle's nervous system. Integration depth matters more than raw capacity alone. This approach mirrors aerospace safety philosophy. Redundancy and awareness are prioritized over brute force. There is also a strategic angle tied to supply chain resilience. Battery manufacturing today depends on concentrated global sources. Donut Lab suggests that its materials sourcing can be diversified more easily. This reduces exposure to geopolitical risk. Governments increasingly view batteries as national security assets. Localized production is becoming a policy priority. A design that supports varied sourcing fits that direction. It also reduces transportation-related emissions, and supply flexibility helps stabilize pricing over time. Manufacturers value predictable input costs. This could make the battery more attractive during market volatility. Stability is often more valuable than peak performance, especially during global disruptions. Another lesser-discussed aspect is recyclability at the end of life. Many solid-state designs face recycling challenges. Complex material bonding complicates separation processes. Donut Lab claims recyclability was considered early in development. Designing for disassembly reduces future waste management issues. Regulators are tightening battery disposal requirements. Companies that ignore end-of-life planning face future penalties. Easier recycling lowers environmental impact. It also improves public perception of electric technologies. Circular economy principles are becoming mandatory, not optional. Battery waste will define the next regulatory battle. Planning reduces long-term risk. This forward thinking could pay off later. The competitive landscape around solid-state batteries is crowded but fragmented. Many firms focus on laboratory breakthroughs without production clarity. Donut Lab positions itself differently by emphasizing execution. This resonates with manufacturers burned by missed timelines. Industry fatigue around exaggerated battery claims is real. Companies now demand validation, not vision. So here's what you need to remember. Donut Lab's solid-state battery claim is a story of extremes. It could be the breakthrough that finally ends the battery era dominated by lithium-ion. Or it could be a textbook example of hype outpacing proof. But one thing is certain. When those first Verge motorcycles roll off the line with these batteries installed, the world will finally have the answers. And we'll all be watching. If you found the video interesting, drop a like, share, and subscribe for more deep content like this. Thanks for watching.